Good day, guys. Welcome to this YouTube channel. And my name is Ayobami, and I'm popularly known as Dr. Ayo, and I am a medical student of Obafemi University. And this channel belongs to Obasco Academy. So Obasco Academy is an online teaching platform that helps students who are preparing to gain admission into higher institutions in Nigeria to prepare for exams like JAMB, Post UTME, School of Nursing exams, WAEC and NECO, just any exam that is what? Admission related. It is admission related. So today, we're looking at the topic physics. We are treating physics, and the topic is equilibrium of forces. Equilibrium of forces. And before I chose this topic to be taught, I did an online survey of topics that students are finding difficult in physics, and a lot of them pointed out towards equilibrium of forces. And I've also found out that people don't really take this topic serious, but instead they touch topics like waves, electricity, and all those popular topics. But today we are not going to do that. We're looking at equilibrium of forces. So this is a quick one. If you know you are seeking admission into any university in Nigeria that requires you to write post UTME, or maybe you want to write JAMB next year, because this video was recorded in the year 2024. So if you're writing JAMB next year, please make sure for your own good to register for Obasco Academic classes, and we'll drop the link in the description below where you can meet with our customer care. So let's go into this class. So we're looking at equilibrium of forces. So what is said what do we mean when we say an object is in equilibrium? So an object is in equilibrium when that body is not accelerated, or when the object rather is not accelerated. That means that body is not moving. So for example, if this marker is on this phone like this, and the marker is not moving, it means this marker is in equilibrium. So let me write it down. So an object is in equilibrium when it is not accelerated. That is, there is no net force acting on it in any direction. So this description is perfect. So an object is in equilibrium when it is not accelerated. That means the body is not moving. If the acceleration of a body is 0, that means that body is not moving. The body is static, is in one position. That is, there is no net force acting on it in any direction. And this is telling you that there are some bodies, or there are some objects in which we have several forces acting on it in different directions. But when you calculate the net force on that body, that is the net force acting on that body, it will be what? It will be equal to 0. For example, let me give an illustration now. This is this marker. Now, I have my right hand and my left hand from where you are viewing though. So if I'm pulling this marker together with my two hands with the same amount of force, you can see that this marker This marker is not moving, telling you that this marker is in equilibrium. But of course, there are forces acting on this marker, but the marker is not moving, because the force on my left hand is equal to the force on my right hand. So when you calculate the net force, it is It is 0, because this marker is not moving. But as I let go of his hand, this marker will go this way. And if it is not moving, that means this marker is not more in equilibrium. So an object in equilibrium is it is not accelerated, and also there is no net force acting on it in any direction. So that body might either be at rest. So for example, if this marker is here, the marker is at rest. So that body might either be at rest, or it might be moving with constant velocity. The body might be moving with constant velocity. And if a body is moving with constant velocity, that means the acceleration of that body is zero, because any object or any body moving with constant velocity, the acceleration is what? Is zero. So let me write that down. The body may either be at rest, let me capitalize it, or may be moving with constant velocity. So these are the conditions for a body to be in equilibrium. Either the body is at rest or is moving with constant velocity. And of course, there are some body that rotate. There are some body that they don't really move from one point to another, but they what? They rotate. So if a body is also rotating with a constant angular velocity, that body is also in what? In equilibrium. So if the body is, let me write it here, rotating with constant angular velocity, it is in what? It is also in what? In equilibrium. So based on this, we have static and what? And dynamic equilibrium. And it's very, very simple. We are talking about static equilibrium. That means the body is at rest. The body is not moving. But when we're talking about dynamic equilibrium, or some people call it kinetic equilibrium, that means the body is what? Is moving with either constant velocity or rotating with what? Constant angular what? Velocity. So do we get that? So we have two types of equilibrium. We have the static equilibrium, and also have what? The dynamic what? Equilibrium. So there are basically two conditions for a body to be in equilibrium. If we are to summarize the whole story that I've been telling you to make it in a more tangible form. So I'll write them down while I pause this video. Just pause. So these are the conditions for a body that is in equilibrium. So to summarize all what we've been discussing here, so a body is said to be in equilibrium when the body as a whole either remains at rest. That means every part of the body or the whole object remains what? At rest, or moves in a straight line with a constant what? Velocity. It's moving in a straight line with a constant velocity. The second condition is if the body is either not rotating or is rotating at what? Constant angular velocity. Just the same thing with this first one, but this one we're talking about what? Rotation, angular what? Movement. Do we understand? So that is that on that. So the next one we're looking at, what we're doing now is that we're establishing some concepts. So I've explained static and what? And dynamic equilibrium. When a body is at rest, it's what's called what? Static equilibrium. When the body is moving with a constant velocity or rotating at constant angular velocity, that is what? Dynamic equilibrium, or you can call it what? Kinetic equilibrium. So please note it. Static equilibrium is different. Dynamic or kinetic equilibrium is also what? Also different. So let's go to the next concept. The next one that we're looking at is what? Resultant and equilibrant forces. Resultant and equilibrant forces. So when a body is in equilibrium and the body has forces acting on it, it means that the sum total of the forces acting on that body is zero. That means when you get the net force the net force acting on that object is what? Is zero. So it is written here that a body acted by two or more forces is said to is said to be in equilibrium if it does not rotate. So under this condition, the sum of the forces acting on the body on one direction is equal to the sum of the forces acting on the body in the other what? Direction. For example, now, if two forces, this is a pulling force, this is another pulling force. If they are acting on this body, the body is a marker. If they are acting on it in different direction. So now, for this body to be in equilibrium means that this marker must not be what? Be moving. Now, at this point, it's not moving. I'm just telling you that the force that is moving this marker, that is acting on this marker in this direction, is also equal to the force that is acting on this marker in this direction. You understand? So that's when we now what? Come to the concept of resultant and what? And equilibrant forces. So let me clean this place and let me explain that. So let's do that here. So let's assume that this is a body, is a block, and we have two forces acting on it. We have this force is going in this direction. Let's call it F1. And this force is going in this direction. Let's call it what? F2. Now, if you want to look for the total force or the net force acting on this block, remember, this force is acting on this block in this direction. Let's say someone is pulling this block in this direction and another person is pulling this block in this direction. If you look for the sum total of the force acting on this body, you will have to get the resultant force. You will have to get the resultant force. So we are looking at the definition of what a resultant force is. A resultant force is that single force which has the same effects in magnitude and direction as two or more forces acting together. Now, if we look for the resultant of this force, that means we are saying that that force has the same effects. That means the effect of these two forces. So, okay, let me put it like this. If we want to get the resultant of F1, which is this, and F2, so the resultant is that force, that single force that has the same effect in magnitude and in direction as these two forces acting together on this object. That's when that what we call what? The resultant of what? Of this object. Do you understand? So let me write that down. Let me write it down in literal terms. The resultant of a force is that single force which has the same effect in magnitude and direction as two or more forces acting together. So, if we are looking for the resultant of this force, is that single force which has what? The same effect in magnitude and what? And direction as two or more forces acting together. So, the way we get resultant force, we use what? The parallelogram law of vectors. So, to look for a resultant force, we use what? The parallelogram law of vectors. So, that's where you apply your cosine rule, and sometimes you might see some cases which require you to use what? The Pythagoras what? The Pythagoras formula. So don't worry, when we are doing calculations, if you don't know what the cosine rule is, we will still look at the cosine formula and we will still talk on the parallelogram law of vectors. And there's one thing I also wanted to know. I have to draw a diagram here. Now we've gotten the diagram ready, and I hope I drew it well. So to explain further, this is two forces now, F1 and F2. They are acting together at this point. Now, what we mean by the resultant force is that single force which has the same effect in magnitude and direction as two or more forces. And these are the two forces. Of course, we really have two forces here acting together. So these are the two forces acting together. So to get the resultant force, we use the what? The parallelogram law of vectors. And when we use the parallelogram law of vectors, we draw the resultant force from the point of the intersection of the two forces acting together. So this is the first force, this is the second force. So when we draw this line from the intersection of these two forces on this point, that is the what? The resultant force. So now, this resultant force has the same effect as these two acting together. So now, if this body, let's just draw a box here. If this body is in equilibrium, that means this body is not moving. But for example, not for example, but this force is acting on this body. That means literally this body will be moving in this what direction. And that does not, that shows you that this body cannot be in equilibrium. But we have one other force, which is called what? The equilibrant force. And the equilibrant force is also, is always in opposite direction to the what? To the resultant force. So let's do like this. So we put E here. This E means what? The equilibrant force. So this equilibrant force is always equal and opposite in direction to the what? To the resultant force. So that is telling that the resultant force and the equilibrant force, they are equal in magnitude. Now, for example, let's say the resultant force is 20 Newton. Let's call it 20 Newton. The equilibrant force will also be what? Be 20 Newton. But what will change is that it is acting in what? In opposite direction. And the function of that equilibrant force is to balance the other forces here, so as to keep this object in what? In equilibrium. That's the function of the what? Of the equilibrant force. So the equilibrant force of two or more forces is that single force which balance all other forces taken together. So that's what the equilibrant force is. Now, all other forces taken together is the resultant force, because we've gotten the resultant of all the force, which is F1 and F2. And we got it as, we assume it to be what? 20 Newton. So that equilibrant force is that single force which will balance all other forces taken together. So that equilibrant force will now also be what? Be 20 Newton. So if 20 Newton is acting on this body in this direction, that is the resultant force, the equilibrant force will be what? 20 Newton acting on this body in the opposite direction. So the equilibrant force is same in magnitude. When I mean magnitude, I mean the value. Is same in magnitude with the resultant force, but what? It is opposite in direction with what? The resultant what? Force. So for example now, if this resultant force is going this way, the equilibrant is going what? In the opposite direction. So if the resultant force is going in the northwards direction, the equilibrant will go what? In the what? In the southwards what? Direction. So it is that simple. It is that simple. So when you have two forces acting at a point or maybe on a body with an angle between them, of course, there's an angle between them. This is an angle between them. There's an angle between them. To get the resultant force, we use the what? The parallelogram law of vectors, where we apply the what? The cosine rule. So one other thing I want to know is that if three forces like this, okay, let me make it smaller. F1, F2, and F3. If they are acting together at a point, the resultant of any of the two forces is the other force. So let me explain the terms. Now, if we are to look at the equilibrants rather. So the equilibrant of these two forces acting together is this one. So the equilibrant of F1 and F2 is F3. The equilibrant of F3 and F1 is F2. The equilibrant of F1 and F2 is what? Is F3. And with that, you can also get the what? The resultant, because the resultant is opposite in direction with the what? With the equilibrant, but they have the same what? The same magnitude. And for you to apply rules like these, the forces must be acting at a point, at a common point, because if they're not acting at a common point, you can't get the resultant, and neither can you get the what? The equilibrant. So the next thing I'm going to do is that we're going to look at pure calculations, where we see, where we take questions that we have to get the resultant force, we have to get the equilibrant force also. So let's move on to that. So guys, we want to look at practical questions that I'll be solving on questions pertaining to resultants of forces. So before we start, let's do some quick recap here. Remember, I said that a resultant vector is that a resultant force is that single force that has the same effect in magnitude and direction as two forces or two or more forces acting together. why that equilibrant, why the equilibrant force is that single force that will balance all other forces taken together. So the equilibrant is equal in magnitude but opposite in direction to the what? To the resultant. So if the resultant vector is 20 Newton, the equilibrant vector, if the resultant force is 20 Newton, the equilibrant force too will also be what? Be 20 Newton, but they are moving in what? Opposite direction. So when we look at practical questions, and the example we're using is an object is acted by two forces of 5 Newton and 12 Newton. Calculate the resultant of the what? Of the two forces. So we are asked here to calculate the resultant of two forces acting together. So we're given 3 case studies. That means we are solving these questions in 3 different ways, or we're looking at 3 different case studies. So the first one says that if the forces act perpendicularly to what? To each other. So I think we can clean this place. The duster, please. Okay. So the question is that if the forces act perpendicularly to each other, so we can, let's write our parameters down first. We have F1 here, that's 5 Newton. We have F2 is what? 12 Newton. So if they act perpendicularly, now if two forces are acting perpendicularly, that means that the angle between them is what? 90 degrees. Let me draw it. Let me use a diagram to illustrate it. Something like this. Let's call this F1, F2. So force is a vector quantity. So you can use vector diagrams to represent it. So this is 5 Newton, and this is what? 12 Newton. And the angle between them is what? 90 degrees, because we are what? They are what? Perpendicular. See, they act perpendicular to each other. So if we want to find the resultant of this force, the resultant is that, in this diagram, the resultant is that diagonal that is drawn from the intersection of the forces acting together. That means the resultant is this line drawn from here, R. You understand? So for us to get the resultant of these two forces acting perpendicularly to each other, we'll use what? The Pythagoras theorem. In this case, we can't use cosine rule. Even if we use cosine rule, when you do cos 90, you will get 0, which will eventually revert you back to the what? To the Pythagoras theorem. So what is the Pythagoras theorem? Is what? Basically, c square equal to what? A square plus what? Plus b square. And this c is what we equate to as what? The resultant. So now, to get the resultant here, we'll do what? R square equal to what? F1 square plus what? F2 square. Just relating to this equation. So what's our R square? The R is the resultant that we are looking for. So R square equal to what? 5 square plus 12 square. So that is 25 plus 144. You get what? 169. Don't forget. So at this point, normal mathematics will get what? The square root of both sides. So square root of 169 should give you what? 13. You put what? 13 Newton. So this 13 Newton is the resultant of these what? Two vectors. So the resultant, is the resultant of these two what? Forces. Sorry that I'm saying vector, because this is, we are solving questions on vectors. This is what you actually do. Because first is what? Is a vector quantity. So this 13 Newton is the resultant of this 5 Newton and this 12 Newton acting what? Together perpendicularly. Do you understand? So let's take the second question. They say that what? If the two forces act at an angle of 40 degrees to each other. Now, if two forces are acting at an angle that is not perpendicular, that is, the angle is not equal to 90, that is where cosine rule, or rather the parallelogram law of vectors, come into play. So let's look at that in this place. So I hope you can see it. So let's draw the diagram first. So these are the two forces. This is F1, this is F2. The angle between them is what? 40 degree. Now, in the parallelogram law of vector, what they basically say is that if two forces or two vectors, let's use forces, because I'm doing equilibrium of forces. If two forces are acting together at one point, the diagonal drawn from the intersection of the point where they are acting is the what? Is the resultant, and is equal in magnitude and direction as these two forces what? Acting together. And that is where we get the cosine rule from. The cosine formula from, which is what? R square equal to what? P square plus Q square plus 2PQ cos theta. So this is the basic formula of what? Of the cosine rule. Let me write the what? The cosine formula. So it's that simple. So this R is the resultant. Why this P and this Q are representing the forces here and here? You understand? When we solve question, we'll change it. So that's just it. So this theta here, remember, this angle here is the angle between the two forces. Please, is the angle between the two forces here. You understand? Please note that very, very well. So let's solve the second question. And the second question says that they act at an angle of what? 40 degree. So if we look at our parameters, your F1 is still what? 5 Newton, while your F2 is still what? 12 Newton. So F1, 5 Newton, F2, 12 Newton. So let's use the cosine rule. So that will be R square equal to what? F1 square plus F2 square plus 2 F1 F2 cos theta. And also theta is what? 40 degree. So our F1 is what? It's 5 square plus 12 square plus 2 into bracket 5 times 12 cos 40 degree. So this is the 169 plus 2 times 5 is 10. 10 times 12 is 120. 120 cos 40 should be 0.76. Name my calculator for that. So cos 40 is 0.766. 0.766. So let us multiply 120 times cos 40. Or let's just do it like that. Times 0.766. So remember R square, R square, R square. So when you multiply 120 times 0.766, then you add that with 169, you get 260 point what? 9. Sorry, I want to write it very clearly. 260.92. So of course, at this point, we are meant to get what? The square root. So that will be square roots here, square root of both sides. So square cancel square root, then R is equal to what? 16.15 Newton. So that is telling you that when these two forces act together at an angle of 40 degrees to each other, we solve to get the resultant, we will solve using the what? The cosine formula. You understand? Then our answer will be what? 16.15 Newton. And one thing you should notice is that if we try to solve this first question with the cosine formula, when you get here, cos 90, because of course the angle here is 90, cos 90 will be 0. If cos 90 is 0, everything here will be what? Will be 0. Then you'll be left with what? R square equal to what? P plus Q. Or you'll be left with what? R square equal to what? F1 square plus F2 square. You understand? So that's just it. So let's solve the third question. The third question says that if the two forces act at an angle of 125 degrees to each other, is it the same thing as this? So for your own good, you can just pause the video and try it yourself and see if you get it. It's quite simple, but let's do it here. Let's do it here, and I'll be very, very quick with that. So still using the cosine formula, what is just changing in these three questions is just the angle. The first angle here is 90, second here is 40, the third here is what? 125. So let's just do it straightforward. So that was r squared equal to f1 squared plus f2 squared plus 2 f1 f2 cos theta. So what changes just what? The angle. So that be f1 is still what? 5. So 5 squared plus 12 squared plus 2 5 times 12 cos 125. So this is 169. That is 5 squared plus 12 squared plus 120. So cos 125 should give us a negative answer. So cos 125 will give you minus 0.57, let's say 4.574. So let's multiply 120 times 0.574. We get 169. Since this is minus sign, this will give you what? Minus 68.88. So not forgetting r square, our r square here, our r square here, our r square here. So 169 minus 68.88 will give you r square equal to what? 97.12. So at this point, you also get the what? The square root. The square root. I can't make any mistake anywhere. Yeah. So the square root of 97.12, square root of 97.12 will give you r equal to what? 9.86 Newton. 9.86 Newton. So one thing about equilibrium of forces is that not the questions are not rigid, they are flexible. So you can be given a question where you just be asked to find the angle between the forces. You can be given a question where one force will be missing and other parameters will be given. You can be given a question where you'll be asked to, even the resultant can be given and they will ask you to look for the F1 and F2. So the questions are different. So we'll look at other case studies. We'll look at maybe like 2 or 3 more examples and we'll go further. So let's take more examples on this question, on questions like this. Not basically looking for the resultant in every case, but at least maybe to look for an angle, to look for a particular force. You understand? So let's get to that now. So guys, we want to look at questions on getting the resultant of forces acting together. But the questions we're looking at now are not rigid questions. They are questions that you can be asked to look for a force, you can be asked to look for the angle. So questions under equilibrium of forces, they are not rigid, they are very flexible. You can be asked to look for any variable aside the resultant. So you must know how these things work. So if you have been enjoying this video, you've been enjoying my teaching, it has been helping you. You can like the video, share, and also please subscribe to the channel and make sure that if you are writing UTME, you are writing post UTME at the time of you watching this video, make sure you register for our classes, and the link to do that will be in the description of this video. So let's move on. So this question says that two forces whose resultant is 100 Newton are at right angles to each other. Two forces whose resultant is what? 100 Newton. So we have been given the what? The resultant. We have been given the what? The resultant. So they are at right angles to each other. If one of them, this is one of them, sorry. So it says if one of them makes an angle 30 degrees with the resultant, determine its magnitude. So in this question, we have been given the what? The resultant, and is what? That is R. R equal to what? 100 what? Newton. And you're like, two forces whose resultant is what 100 Newton are at right angles. Right what angles. So if we are to represent this question in a diagram, it will be like this. These are the two forces, F1 and what F2, because they are what they are at what right angles. They are at what right angles with what each other. So if one of them makes an angle 30 degrees with the resultant, that means the resultant will be what will be drawn from this point, and the R is what 100 what Newton. Then put the arrow, and the R is 100 Newton. Then they were like, one of the two forces makes an angle 30 with the resultant. Let me see a blue marker here. Makes what an angle 30 with the resultant. So this is the what angle 30. So you can put it here or put it here, but for convenience sake, let's just use the angle to the what to the horizontal. So like if one of the forces makes an angle 30 with the what the resultant, so the angle is between this force and the resultant, then they were like, find the what the magnitude, determine the what the magnitude of that force that makes an angle 30 with what with the resultant. So how do we go about this? There are several ways we can go about this. We can use the sine rule, and we can use normal trigonometric ratios. Do you understand? So let's just do it this way. So one thing you must know is that if you have someone that you've tried questions on that vectors, or you've studied vectors, you know that when you're looking at the resultant of a vector, because forces are what vector quantity, so we can represent them with what with vector. So one thing you should know is that the so in this diagram, we have two components. We have the what the vertical component, and we have the what the horizontal what component. What we call what the y-axis and the what and the x-axis. So the resultant is related to the what to the x-axis through this formula. That is r cos what cos theta will give us what f2. Do you understand? R cos theta will give us what? Will give us f2, and r sine theta will give us what? f1. Do you understand? So the resultant cos theta will give us what? f2, and the same resultant sine theta will give us what? f1. Me saying that this is what? The x component. And this is what? The y component. Understand? So you can write it as ry cos theta and what rx cos theta to signify that okay, this one is for what the vertical axis and this for the what the horizontal axis. So since we are looking for f2, we use the formula for what the the x component or the horizontal what axis. So okay, sorry, this should be rx. Sorry, rx. This should be what ry. So this is what the horizontal axis, and this is what the vertical what axis. So 100 cos 30 will give us what f2. Is that simple? 100 cos 30 will give us what f2, and that is what cos 30 should give us 0.866 thereabouts. Cos 30. Yeah. So we have 100 times 0.866 equal to f2. Therefore, f2 is equal to what? 86.6 Newton. So that force that makes an angle 30 with the resultant is what? 86.6 Newton. So please, this thing or this formula will help you in a long way in physics. Understand? So physics is interrelated. You should know the basics for you to be able to solve complex questions or complex equations. This is not complex, but I'm just telling you that these are what they are basic things. They are basic things. So if you have something like this, the resultant cos theta will give you what the horizontal component, while the resultant sine theta will give you what? The vertical component. So this F1 is the vertical component. This F2 is what? Horizontal component. And this is how you go about it. Or make sure you look at this and you study it well. This is the fastest and the simplest way. This is the simplest way, depending on the one you want to use. Or you can use the sine rule. So let's just go quick by using the sine rule. So using the sine rule, we have to create a triangle. So now, if I draw a dotted line here, of course, this is not drawn to scale. So you can just go like this. So if I draw a dotted line like this, one, like this. Now, this dotted line is also representing this F1 here. They are equal, they're the same thing. So we can do this as what? As F1 also. So we are typically looking at a triangle here now. We are looking at a triangle from here to here to here is a what? Is a triangle. So now we are going to use what? The sine rule. And in the sine rule, this is sine rule. Is okay, name is the black marker. Is what? A over sine A equal to what? B over sine B equal to what? C over what? Sine C. Of course, in the sine rule, you only use 2 out of the 3. You can use A over sine A with C over sine C, or B over sine B with A over sine A. You're just using the 2 out of the 3. So this ABC represents what? The sides. Why this sine A, sine B, sine C represents what? The angles, the corresponding opposite what? Angles. So if you want to look for the force making an angle 30 with the resultant, that means we're looking for what? We're looking for what? For F2. So we'll use the sides that they already have an angle. So let's go about it now. So the angle here will be what? Since it's the right angle triangle, it will be what? Angle 90. Here will be what? 90 degree. Now, if here is 90 degree, here is 30 degree, what will be here? You know that in a triangle, the sum total of the angles is what? 180 what? 180 degree. So if here is 90, here is 30, of course, here will be what? 60. Because 90 plus 30 is what? 120. Minus 180 will give you what? 60 degree. So let's take here as, let's use A, B, C, right? Okay, let's make it like this. Let's make this one A, B, C. So let's use this part with this part. So that will be what? 100. The angle opposite this side is what? Is 90 over sine 90 equal to what? We're looking for this F2. So let's use F2. That will be what? F2 is B. So that will be what? F2 over what? Sine. The angle opposite F2 is what? 60 over sine what? 60. So if I have to multiply and look for F2, that will be F2 is equal to what? 100 times sine 60 divided by what? Sine 90. So sine 90 is 1. That will be 100 times 0.866 divided by what? 1. You still get what? 86.6 Newton. So it's that simple. So the sine rule is not something complex. It's also what? Also quick, based on how you understand it. So I hope no confusion. But let me just recap some few things. This 30 degree was there before, and we just use sine rule. And the reason why I even labeled here A, B, and C is for your own understanding. I could literally do this without using this A, B, and C and just do it normally. 100 divided by what? The angle opposite it, which is what? 90. Remember, this angle 90 is opposite this 100. So 100 over sine 90 equal to what? F2, which we're looking for. And the angle opposite F2 is what? 60. So F2 over what? Sine 60. If we were looking for F1, it's what? F1 over what? Sine 30. So the side and the what? Angle opposites. The side and the angle opposite it. That's how we use what? We use sine rule. So guys, let's move to the next question. So the next question says that the resultant of two forces, 12 Newton and 5 Newton, is 30 Newton. Now it says that the resultant of these two forces, the first force is what? 12 Newton. And the second force is what? 5 Newton. And you're like, the resultant is what? 30 Newton. then we are asked that what is the angle between them. I think I'm safe to clean this. You can just pause the video and go over it again if you want to. So the resultant of two forces, let's write our parameters down. So R is equal to what? 13 Newton. The resultant here is 13 Newton. And the forces F1, F2 is what? 12 Newton and what? 5 Newton. Then we're asked to look for what? The angle between them. So in this question, you were not told that they are acting perpendicularly to each other. So please note that. Don't go and assume that because 12 and 5 then just like this, that they should be like this. No, this is not actually a diagram. And you cannot just assume or come to conclusion that this is how it should be. What you do in this question is to use what? The cosine formula. So even if they are at right angles, the cosine formula will help you prove that by getting your angle to be what? To be 90. But now we don't know the angle between them. So we're asked to what? To look for that. So what do we do? Very, very simple. Very, very simple, my friends. So just draw the diagram. Drawing the diagram is not really necessary, but for your exam, for your own understanding. So something like this is 12 Newton, this is 5 Newton, and the resultant, 13 Newton. Now look for the what? The angle between them, theta. It's as simple as that. So we use what? The cosine rule, which is what? R square equal to what? F1 square plus F2 square plus 2F1 F2 cos theta. It's that simple. So what is the resultant? 13 Newton. So that will be 13 square equal to what? 12 square plus 5 square plus 2 times 5 times 12 cos theta. We don't know theta. We are looking for what? For theta. So this is what? This should be, theta should be 169 equal to 169. Yeah? Let me see something here. Yeah, 169, 12 square, 144, plus 25, 5 square, that's 169, plus 2 times 5 is 10. 10 times 12 is what? 120 cos theta. Yeah. So we can collect like terms here. And 169 minus 169 will go to what? 120 cos theta. So what is 169 minus 169? You get what? You get 0. I think I have to clean this place and move to that board. Yeah, so 169 minus 169 is equal to what? 0. So that will be 0 equal to what? 120 cos theta. So we are looking for what? The angle. So that will be what? Cos theta equal to what? 0 divided by what? By 120. Which will give you what? 0 again. So cos theta equal to what? 0. So we are looking for what? Theta. So theta equal to what? The cos inverse of 0. Which should give us 90, I guess. Yeah. Yeah. So the cos inverse of 0 will give us what? 90. So the angle between them is what? Is 90 degrees. So it's that simple. So the angle between them is what? Is 90 degrees. So in most cases, you won't see 0. You will see a real value. But just follow the same step and you will get your answer. So, yeah. So any confusion, there's no confusion. Just the normal way of doing things. And please, when you are solving questions like this, be careful of your signs. There are cases where you might have negative signs. So please be very very, very, very careful. Be very, very careful. So I think that's all. We've looked at more examples. So let's go into more examples and we'll move to the next section.